up to YouTube, at least one of my 4 lessons that I do today, right? So if you miss it, it's recorded. Go to the class website, it's there. So there's a few people away. They actually emailed me last night, said, Mr. Jolly, well, I got a dentist appointment, I got a game, so I won't be here. So they'll see exactly what we're here. All right, so we're going to learn how to multiply really fast. So if I gave you an expression like 7 times 7 times 7, that's multiplying. You've seen stuff like that before. But that written with exponents looks like this. All right?
7 to the power of 3.
7 to the power of 3. We use that terminology quite often, 7 to the power of 3. Now, technically, like I say that, but that's technically not how you should say it. And we'll talk about terminology well. It's like 7 to the exponent 3, but everyday language, we use 7 to say 7 to the power of 3. Right?
3 to the power.
All right. Now, this whole thing is called a power. Right? And the thing that's floating up in the air is called the exponent. Exponent. All right? All right? Then the number that is being repeated, or the thing that's being repeated, is known as the base. Okay? So, the base is anything that the exponent is being applied to. That's what gets repeated. And this whole thing is known as a power. Right? I'll tell you, you're going to have a quiz. And one of the questions is going to be, hey, look at this expression. What's the base? What's the power? What's the exponent? You got to know these terminology. That's the language of math, and we need to be able to communicate, right? Okay. So looking at this expression here, and I asked you, what is the exponent? What would you say? Right? So what is the exponent here? Gershan? 5. Right? Okay, next. What is the power? Yes, Oliver.
3.
Nope. Max?
The negative 3 and the floating 5.
Yeah, actually everything we see here, including those brackets, right? So the negative 3 and the 5, the whole thing. All right. Now, the base sometimes gets a little tricky. So the base is what gets repeated each time. The base is whatever the exponent is touching. So in this expression here, this exponent, you look to the left, what is it touching?
3.
The 3 or this bracket, right? So the base is everything that is a part of this bracket. That's what it's touching. So the base is that bracket, and it had the negative 3 a part of it, inside of it. Okay? All right. So if I wanted to write this out the long way, like this, this would say, hey, we have the exponent 5. This means we're going to multiply the base 5 times over. So this would look like negative 3 times negative 3 times negative 3 times negative 3 times negative 3. And you can tell that this is a much more efficient, easier way of writing things, because if this number gets big, this gets exhausting to write out. Right? That's what it means. All right? Okay. Everybody good? Nice. First thing in the morning on a Friday. All right. Okay. So now we have this expression with 3. 3 times 3 times 3 times 3. Can somebody work that out? Can you multiply that in your head or use a calculator? Tell me what this equals.
12.
Yep. It would not be 12. Yes, Oliver.
Is it 3 to the 4th power?
No, that'd be written as exponent. What number is it? If you multiply 3 times 3 times 3 times 3, what do you get? Goshan? 81. Right? So if you just grabbed your calculator and you went 3 times 3 times 3 times, oops,
That's sick.
times 3, you get 81. Right? Yes, Mikey.
Got something to eat.
No, man. We're doing math.
Where
Can I go to the bathroom after we're done this?
Yes. Yes, Max.
do you get that calculator?
This is a graphing calculator, and depending on your teacher and what you're doing in math, in grade 10, you may be able to use this, or most likely in grade 11. If you're going for the academic math, you'll be using a calculator like this.
That's dope.
Okay. All right. So now,
How do you get
Oliver
the computer?
jumped one step ahead. He goes, this is 3 to the exponent 4. So that, if I want to write, it would be 3 to the exponent 4, like this. All right? So this is called the exponential form. All right? So writing it like this is called exponential form. Writing it like this is called repeated multiplication. All right, so you basically need to know that terminology because the question is going to say, hey, write this as a repeated multiplication. You got to know what it's asking. It's not asking anything hard, but you just got to know what it's asking. Right? So, exponential form as a power, repeated multiplication, write out what the multiplication is. Right? And the word evaluate is asking you to say, what is this equal to? All right? Now, Gershon calculated it out. He did it 3 times 3 on his calculator. It was 81. Right? And which is fine for today, but we don't want to be doing that because that is slow, especially when the numbers get big. So you need to know how to use your calculator to do exponents. Right? So this is where it gets a little tricky. Now, hoping that many of you guys have your calculator. Now, who's got a calculator here? That's the scientific one. All right? Okay, so me and Miss Kirby are going to help you guys out. All right? Now, depending on your calculator, we have different buttons that do exponents. All right? So on your calculator, generally the exponent button looks like x, y, or yx, or maybe AB or BA reversed, or this upside down V that is called a caret. So look at your calculator, see if you can find that button, right? And for my calculator, we use the caret button, and I'll come around and help you. So what I want you guys to do is press 3, then your exponent button, and then the exponent. And when you do it, you should end up with the same answer, 81. Should not be a surprise. So I'll come around and I'll help you, and Ms. Kirby will help you, and I want to make sure that you guys get 81. Because I don't want you losing marks on the test just because you don't know how to use your calculator. That is a very silly way of doing poorly for no good reason. All right. Wait for the lesson. All right. So, we're following around, writing these things out. All right. There's a screen. What's going on? All right.
Help you?
Does anybody need help with the calculator?
I can help.
Yeah, I need help.
No, I'll help them. So your exponent button, let's see, would be this one. So you go hit 3, then your exponent button, then 4. Right? And hit 4. Okay? Okay. You don't have a calculator. Anybody else have any issues with calculator? Okay, there we go. So your exponent button is this one. Right? So you hit 3, that one, 4. There you go. Excellent. Sam, you got yours figured out? Awesome. Hmm? No? Need help? That's the one. So hit 3, or that one, and, oh, you have decimal. 3, that one, 4. Yeah. Awesome.
That's what you did.
Okay, got it, Elena? Okay, so your exponent button is this one. So you're probably gonna hit 3, your exponent button, and then 2 equals. Okay?
And I don't need to press second.
No. Okay, everybody's got a calculator, got that figured out? So if you don't have a scientific calculator, what you're gonna have to do is multiply it out the long way. Go 3 times 3 times 3 times 3. And if that number is 15 as the exponent, you're gonna have to do it 15 times. All right? So get it for Monday. All right, so this equals 81. All right, now, remember, it means multiplying the base 4 times over. When you write things like this, these are also known as factors. Okay? There are 4, no, maybe I'll use the number 4. 4 factors of 3. Right? So we do factoring in grade 10. I may need to do some more factoring stuff at the end of this year, see how it goes, right? But just another terminology to know. So all these things, just words that you need to know. Okay. Now, let's slide on over here. All right, we go up to the right-hand side. Okay. Can somebody? Sorry. Scissors. Yes. Yeah. Can somebody calculate what this would be using exponents? Yes, Alana?
16.
Yeah. So if you use your calculator, it should be 16.
Yep.
4 squared. Thank you, Sam. Hey, Sam.
Yeah.
Can you tell me how this looks like as a repeated multiplication? Two.
Yes, I can. It is 4 twos.
4 twos. All right.
4 times
4 times 4. Right. So if the question asks you to write a repeated multiplication, that's all I'm asking for. Now, if you have an exponent 2, lots of time that shows up in math quite often. Some things with exponents 2 or exponents 3. And we give those special names because we use it so often. So we can read this as 4 squared. Right? If you hear somebody saying 4 squared, that means it has an exponent 2. Because we do exponents 2 a lot in math. So read as 4 squared. Or we can say 4 to the exponent 2, but that's the common way we say it. And the reason is because if you go 4 times 4, that is an area question, right? Length times width. You end up with a square. So 4 times 4, you end up with 16 boxes inside. Right? Okay. Can somebody do 2 to the exponent 3? What does that equal?
8.
Mirka, thank you. All right. Now, if we were to write that as a repeated multiplication, what would that look like? Right? Alana?
2 times 2 times 2.
Yeah, 2 times 2 times 2. And if you don't have a scientific calculator yet, that's the way you're going to calculate this out. Right? Or you use your hands, or you use a multiplication sheet. Right? Now, exponent 3s, yes?
Well, I was going to answer the next one.
Yeah, oh, not yet. Yeah, but exponent 3s is another special exponent. We use 3s a lot in math. So anything with an exponent 3 is read as cubed. Read as 2 cubed. Right? And if you the tie back is to grade 8, is when you multiply 3 numbers together, you get length times width times height, which was your volume equations. Right? And that was where the cube came from. Right? So that's how all these things are interconnected. So we have 2 in this direction, 2 in this direction, and 2 in that direction. All right. All right. Next one up. 5 cubed. What does it equal? What do you evaluate it as? Yes, all right, I'm going to say the names here. Jack.
125.
125. That is correct. All right. If you write it as a repeated multiplication, what does that look like? Sorry, I'm going to ask here, Phoenix.
5 times 5 times 5.
Yes. Okay. Okay, moving on down. Okay. I'm going to ask in the first question, what is the exponent? What do we have as exponent here? Yes, Max?
4.
4. That's the exponent. What's the base? Sorry?
Is it negative 16?
No, I'm not looking for the answer. What is the base? I'm looking at terminology here. Yes, Phoenix.
Negative 2 in the brackets.
Negative 2 in brackets. All right? So remember, it is the base that gets repeated. Right? So it's not the negative 2 that's going to be repeated. It's the whole bracket. So what this looks like is the base being repeated how many times?
4 times.
4 times. Thank you. All right? Now, dealing with brackets and negatives, sometimes with exponents, your calculator can do funny things, right? So sometimes your calculator won't give you the right answer. It's just the way they're programmed. Looking at this expression, I'm going to ask you a question. Can you tell me if the final number is going to be positive or negative?
Negative.
I have lots of negatives. People, anybody disagree? Phoenix. And Phoenix thinks it's positive. Phoenix and Max?
Yeah.
You agree with Phoenix? All right. So Phoenix, you're the odd man out. Why did you think it's going to be positive?
I don't know. It's what my calculator said.
Is that what your calculator said?
Because negative 2 times negative 2 would be a positive.
Yeah. Okay. And Oliver?
Well, I think because you keep multiplying all those,
Yeah.
I don't know, because then it'll go past 0 and turn into a positive.
So what I'm looking for here, something from last year. If you have a negative
There you go.
times a negative, who knows that a dot means multiplication? Just a few of you guys? So multiplication can come in a couple of different forms. You may be used to the x, right? But a dot also means multiplication. Now, when we start using letters, using x as a multiplication can get confusing. Because if you have the letter x and using x as multiplication, sometimes it's hard to tell those apart. So you use the dots. Right? So when you had two negatives, that equaled a positive. But if you had a negative and a positive, that equaled a negative, right? So, and if you multiplied longer strings of numbers, if you had an even number of negatives, it was going to be a positive thing, right? And if you had an odd number of negatives, your answer was going to be negative, right? So looking at this, do we have an even number of negatives or odd number of negatives?
Even.
Even, positive, or negative? Even means positive, right? So sometimes I'm going through this process because not everybody's calculator spits out the right answer, right? So now, if you want, you can go 2 to the exponent 4 in your calculator, or if you can and know how to use brackets, you can do that as well. So you can go 2 to the exponent 4 because you know it's going to be positive, or if you wanted to type the whole thing in, you have to use brackets, which some calculators are not so friendly with doing it. I have a big fancy calculator. It goes through easily, but it gives you the same answer. Right? So this requires a little bit of thinking, right? So you want to figure out what the last number is. All right. Okay. Next up. I do not like this question. This goes down to, I like math because math is like usually black and white, right? Question like this is more about conventions, how we read numbers, okay? So I'm going to ask you, what's the exponent here? 4, all right? What's the base?
-2.
No, it is just the 2. Right? This is the one thing I don't like about this. The convention of math is you just look at the exponent and what's it touching. It's only touching the 2. This negative is not a part of it. Right? So the way we read this is, hey, we have this negative sitting outside. We call that basically a -1. Right? Then we have that 2, which is the base, being repeated. So it's going to be repeated 4 times. All right? Now if we calculate this, without even using a calculator, is the answer going to be positive or negative?
Negative.
Negative. We only have one negative here. So negative what? Negative 16, right? All right? So these are the things I want to be aware of. We start off this lesson and you go, oh my God, this is so easy. I can do this, no problem. You get this. And we get to these kind of questions here. Not much harder, but just requires you to think a little bit and not necessarily trust your calculator 100%. See, some people's calculator will do this correctly if you punch it in. Other people's calculators will not. So if everybody had a calculator, I could probably say 30% easily would not do it correctly and 70% would, right? So you need to be aware of what it actually means and just use your head. Okay, next up. What's the base and what's the exponent? So, Max?
The base is the -4 in brackets.
-4.
Exponent is the 3.
And the exponent is the 3, right? So it is the base that gets repeated. So the brackets are being repeated. So -4, -4, -4. All right? Is the answer positive or negative without even calculating?
Negative.
Negative. We have an odd number of negatives. It's going to be negative. All right? Now, in your calculator, you can just calculate this.
-64.
All right? So 4 to the exponent 3. Sam, what did you have?
-64.
64 or -64. All right? Okay. Stepping up the difficulty even more. Throwing in more brackets and more negative signs all over the place. Okay, what's the exponent? What do you think, Otis? What's the exponent? What's the number floating in the air? No? 6. Right? The exponent is the number that's floating in the air. What's the base, Alana?
The bracket -3, but the negative on the outside isn't part of it.
This is not part of it, the negative on the outside. So this is your base. So if you rewrite it as a repeated multiplication, all right, rewrite that negative that's sitting outside first. So we write that as a -1. Then we go the base. We're going to repeat the base. How many times?
6.
6. Four, 5, 6. Okay. Without using your calculator, is it positive or negative?
It is negative.
The negative. How do you know, Sam?
Odd number.
I looked at my calculator.
I said without your calculator, man.
I already looked at it before.
It's an odd number.
It's an odd number of negatives. All right? So it's going to be, you know the final answer is going to be negative. All right? Then use your calculator. What's 3 to the exponent 6? Calculate that. Gershon? -729. All right? Not too bad? All right? Not too bad? All right? So with this lesson, it's terminology. That's the first hurdle, right? Know what a base is. Know what exponent is, right? Then the next tricky part is those negatives. Is a negative being part of the thing that's being repeated or not, right? So let's see. We have 8 minutes to go.
All right.
All right.